So in our today's class, we are going to start next chapter in physics. That is what is actually work and energy and as well as power. So if you have noticed it here, already many concepts in this chapter we discussed it in foundation course itself. That is what when we are studying the gravitation chapter. So in that itself, many concepts I already taught you. Am I right, everybody? So kinetic energy, derivations and all. Already we have discussed it. But of course, this is for school. So we'll continue now today. Now let us observe very carefully, all of you. So work, energy, and as well as power. So this is one of the most important chapter which will come again in class 11th also. So if you see here, if you observe in our daily life, from the basic, from the beginning, I'm saying you again. So we all knows that we'll consider some useful, like we can take a physical or mental labors as basically we'll consider as a work. So if you take like physical labors also, we'll say it as yes, my work is done. Or mental labors like thinking or sitting and thinking about something, or we can say like normally thought process or whatever we used to call it as a work is done. But consider certain activities in our surroundings. If you take, for example, a boy riding a bicycle, a man moving on a staircase, like some boys climbing a staircase, or a student is studying. For example, someone of you is reading, or a daily wage is carrying a weight on his head. So in this, all the activities, riding a bicycle, climbing a staircase, studying the book, carrying the load, all these activities, if you see, the person is involved in doing a lot of mental and physical labor. Am I right or wrong? Everybody, please respond. If you don't have a mental cooperation, do you think that you can read the book? If you don't have a mental physical strength, if you don't, do you think you can carry the load? And if you're carrying a load means definitely your mind should say, yes, you have to keep in your head like this position. Otherwise it will fall down. Like that, every activity if you take, bicycle riding, if you're not mentally not proper, so what will happen? Is it possible to ride the bicycle if you're mentally not proper? Everybody? Yes, please respond, guys. No. And if you are physically not fit also, it is not possible to ride the bicycle. So now it's all these cases, if you see, so we are doing a lot of mental and as well as physical labor. So every action of your life, so there will be definitely a mental means mind also we have to use it. Physically also you have to fit and psychologically you have to fit. So every work involve both mental and as well as physical labor. Now we can say that all are doing work. The boy who is studying also doing work. The boy who is sitting also doing the work. The boy who is running. A man who is climbing the staircase. A boy who is carrying the load. All are, we can say, they are doing the work. But if you observe, we can say in terms of science, if you notice it, normally we can say mental or physical labor, everything is called it as a work. But if you say the science, the meaning of work in science is different from the meaning in everyday life. So everyday life, either it is a mental labor or a physical labor, we can say work. But coming to the science, we will discuss what is the scientifically, what do you mean by work? How we can define. That is what we'll discuss it. So we'll see here while doing the activities in our daily life. Human, if you take, we are all human beings. And if you take animals, they need energy. Suppose if you are listening my class, you need some patience or you need energy. Otherwise, it is not possible. So if I am teaching now, continuously shouting, I need energy to speak. This all the energy for us, for listening purpose or for writing purpose. Now many of you are writing. So and listening also. For this all, where are you? Are you getting energy from where? Anybody? Yes, please.
Food.
Food. So that is what? The energy which is required for us is we are getting acquired from the food. So the requirement of energy is depends on the type of the work which is performed by all the living things. So suppose if you are walking, different energy. If you are running, amount of energy is different. So when we use the energy in walking, jumping, writing, thinking, we'll see the relation between the work and energies will be there. That is what we will say. If you take missions like TV, fan, refrigerator, bus, car, they also need energy for doing the work. Fan is rotating and doing the work. Bus is moving and doing the work. Washing machine running, rotating and cleaning the clothes. This all the things also how they are doing, because they are non-living things. They cannot eat food and get the energy. So for them, they need different energy. What is the energy to run the fan, to run the TV, to run the refrigerator, to run the washing machine? Everybody.
Electrical energy.
Electrical energy. So based upon the type of work, the energy requirement is different and the type of energy is also different. So that is why how much energy is consuming, how much energy is releasing, that is what is the term we will say, another physical quantity, which is call it as a power. So this power is also related to the energy and work done, both. So these are the main things we are discussing in this chapter. So I hope you all understand now what is work, what is energy, and what is power. So let us discuss the scientifically how we will define the work. That is what is our question. Now, let me take again 4 activities I will give you. Activity number 1. A boy going to the market from his home on a bicycle. So what is activity number 1? One boy is there. He is going to the market in his bicycle. So that is what is the case number 1. Case number 2. Pulling a table from one corner of the room to the another corner. So imagine you are having a table in our room. Now you push it to the another place. Just you have bought it here and you have been kept it. So this is the case number 2. Next, case number 3. A big load is present and one man, he has been lifted this load. Lifting the load. That is the case number 3. Next, you are going to the roof of the home with a book in your hand. You are climbing the roof, staircase, and finally you reach to the roof of your house. You are climbing and you are reaching to the roof with a book, with a physics book, for example. So if you see here, or let me take case number 5. A bull cart or horse cart is there. Now this is pulled by the horse. You all can notice it. So horse is pulling the cart. Horse pulling the cart. So now if you have noticed it here, all these activities, if you notice it, according to the science, if you see, work is said to be done. Why and how? Let us observe. Mister, let me take a boy from us. So then you all will understand. Let me take Mr. Mugesh is riding a bicycle and going to the market, or Mr. Mari is pushing a bench from one corner to the another corner, or Mr. Sam is lifting a load from the surface to his head, and another boy, Mr. Sanjay, is climbing his roof with a physics book, or another person, a horse riding, and the horse is pulling the cart. So now all these 5 cases, I will say, according to the physics, work is said to be done. Why and how? So if you notice it, all these above activities, there is a 2 things in common. Can you tell me, everybody? What is the 2 things? If you notice all these 5 actions, 2 things are common which you are noticing. Anybody can tell?
Displacement.
Yes. The body having some displacement, of course, that is the first thing, not the first thing. First one, every case force is applied. Have you noticed it, everybody? Every case the force is applied. Otherwise, it is not possible to lift the load. Am I right or wrong? It is not possible to ride the bicycle. It is not possible to push the bench. It is not possible to walk. It is not possible to pull the cart. So every case force is applied. Next, second case. What is the second case, everybody? What is the second case? Every case you are noticing what? Having some, everybody. Having
Displacement.
some displacement. That is only ways to call it as work. So according to the physics, so what is work, everybody? According to the physics, please respond. So force is must be applied at a body and body moves in the direction of force. Then only it is called it as work or work is said to be done. I hope you all clear. Anybody having any doubt, you can ask me. Are you understand, Aman?
Yes, sir.
Okay,
Yes, sir.
do it fast. See, understanding concept, if you have been taken, so you have to be extra careful and you have to answer the question. That is what very deeply you understand. Definitely you will make it best. Okay, Mr. Darshan, what is happening? Okay, are you there in the meeting? Make it quick. So this is what is about what is work. Now from this, can we form a definition? A beautiful definition you can see. So what is the two important conditions for the work is to be done according to science? According to science, I need two important conditions for work done. What is that, guys?
Force and
Force.
displacement.
Force is the one important conditions. What is the importance conditions for the work? Is first one is what? Force. And the second one is what, everybody? It must be having the, yes, please.
Place.
Displacement. That is what you have to remember it. So what is the definition of work done? So work, write it. Work is said to be done. Work is said to be done. Said to be done when a force is applied. When a force is applied on a body, and the body moves in the what? Mari, can you hear me? Body moves.
Yes, sir.
Yeah. And the body moves in the direction of force. That is what we used to call it as a work done. Or work is said to be done. Work is said to be done when a force on a body, produces what? Anybody? Produces displacement. That is very, very important. Displacement in it. When
Sir, I have
anybody,
a doubt, sir.
yes, work is said to be done when force on a body produces displacement. Force must be applied and it has to produce the what? Displacement. That is what we used to call it as a work. So make it quick. Anybody having doubt, you can ask me or else we'll proceed further. Understand, Alfin?
Sir,
Yes.
sir, only if the force is applied and displacement occurs in the direction of force is it considered to be work done?
Yes,
Or if it
if it is
moves in the
opposite one
opposite.
also, we can say work is said to be done, but that is negative work done. We'll discuss it. Now, presently, we are talking about only about the work. We are not talking about the types of work and all. We'll discuss it, that is all. Okay.
Okay. Okay, sir.
Understand, Hasini Sudhakar? Hasini? Mari. So now, if you have seen here, so what is the important conditions for work done, everybody? Force and displacement. Correct? Everybody?
Sir.
Yes. So now if you see here, 1 minute. Okay. So now if you have noticed it here, if any one or both are absent, note it. Either force is absent or displacement is absent or both are absent, then no work is said to be done. So that is why you have to be very careful. Okay. So write it, everybody. So what we are saying, if any one or both are absent, if any one or both are absent, then no work is said to be done. Why? Because either force is zero, this total work done is zero, either displacement is zero, total work done is zero. So that's why it is totally zero. Now, for example, I will say there is a boy who is sitting in the bench and writing a book. Imagine that. A boy who is sitting in the bench and who is writing something. So suppose now you are all sitting in the bench and you are listening the physics class now. So are you people are really doing the work? According to physics, what is your work done? What is your work done, guys? But of course, you are having a lot of mental labor. You are listening, you are trying to understand, and you are trying to respond to me, and you are trying to note something. But what is your work done? That is what is my question. All of you.
Zero.
Yes. Zero. Why? Why is zero? Of course, you have a lot of mental labor. Why is zero?
No force is applied and displacement is
Yes.
zero. Sir, no displacement
No
is there.
displacement. Mental force is there. Since he is not moving, since you are not moving, since I am not moving. So, any work according to the physics, the person who is sitting and writing anything, sitting and listening, sitting and doing some other XYZ, according to the physics, the work done by him is what? Everybody? Not doing any work. Clear, everyone? So, not doing any work according to physics. What is the reason? According to physics means always work done must be two conditions. What is the conditions? One is force and another one is displacement. Are you clear, everybody? Yes, please.
Yes, sir.
Yes.
Yes, sir.
So this is what is about it. Now, examples of work done. If you take many examples, we can take. I already given you 5 examples. So you can take any example for explaining the work done. So if anybody having any doubt, you can ask me. Writing is considered as a work done, but writing is not a work done because it's a non-living thing. You are spending energy, but your body is not displacing. But if you are throwing the book or if you are lifting a book, it is said to be work done. You understand? And letters are
Yes, sir.
not moving. Letters are in a fixed position. So pen is moving, but force we are applying perpendicularly. Have you checked it? If I apply the force perpendicularly, the pen will write. And the pen is moving like this. So it is not any kind of displacement. Just we are writing a letters. Of course, our hand is moving. Our hand is doing the work. But whole body, if you consider, work is said to be what? Zero. That's all. Okay. So examples of
Yes,
work
sir.
done. You can write many examples you have. So already I have told you. So all the examples of the same thing. So now, whatever the daily life situations you have, where involving the work, you can make an example in our exam if they will ask you. Now, factors on which the amount of work done depends. That is a very important. So let us write that one and then we'll proceed. So all of you write it. Factors on which the amount of work done depends. Factors on which in which the amount of work done depends. Factors on which the amount of work done depends. First one. So only two factors. One is magnitude of force. Magnitude of the force. And second one is displacement of the body. Displacement of the body. So magnitude of force, for example. So actually magnitude of work done, all of you remember, work done symbol is I'm taking W. So directly proportional to force. Okay, everybody, same way displacement. Direct amount of work done is directly proportional to displacement. So either the body displaces more or the amount of applied force is higher, whatever it is, the work done, overall work done will improve or increases. That is why these are the two factors which will affect the amount of work done by the body. That is what you have to remember. I hope you all clear, everybody. Yes, please. All of you?
Yes, sir.
Yes. So now, if you think, like you can see, let me write that, everybody. So if you write work done by a constant horizontal force, so then what is the formula? That is all we are going to discuss now. So if I take, for example, there is an object on the surface. Let me take the point is A. So now finally I have been moved this object to this point. Let me take that point is B. So displacement by the body is S from A to A. So on the force applied on the body is actually a constant force, horizontal force, and the body is in motion. So then the amount of work done, keep the heading, work done by a constant horizontal force. Horizontal force. Work done by a constant and horizontal force. So we all know, just now we studied, work done is directly proportional to force and work done is directly proportional to displacement. So the work done by the body is actually the product of force and displacement. That is what is the meaning of work. So all of you write. So work done is the product of force and displacement. Force and displacement of the work. Sorry, force and displacement of the body in the direction of force. In the direction of force. That is what we used to call it as a work done. So now if you take here work done, so what is that, everybody? Work done is equals to, Kavya, can you hear me? Alfin? So work done is equals to force into displacement. See, this much slowly, neatly teaching, because every concept will come again in later classes. It is simple or tough, it doesn't matter. You should learn very perfectly. That is what work done is equals to force into displacement. So it is the product of the magnitude of force and displacement of the body in the direction of force. That is what we used to call it as a work done. So work done is a vector quantity or scalar quantity, everybody?
Vector quantity.
Vector quantity. No, it is a scalar quantity. It has only magnitude. It has only magnitude. But I won't say I have done 10, like we can say 10 joules of work done in one particular direction. No direction is mentioned. We are not separating. We are not separating the direction. So that is why, understanding, we are not specifying the direction. That is why no direction for it. Only it has magnitude. It has no direction. So that is why we'll say work done is the scalar quantity or vector quantity. Everybody, it is the
Scalar
scalar
quantity.
quantity. That is what you have to remember. Okay, so write it. Work done, it does not specify the direction, only it has a magnitude. So it is why we used to call it as scalar quantity. Okay, everybody, all of you do it. Next, units of work done. I forgot to wish you all happy Children's Day, everybody.
Thank you, sir.
Yeah, I
Thank you,
forgot. Yes, yes. Thank you. I forgot. Sorry for that. Even 10th class also I forgot it. That's fine anyhow. Wish you happy Children's Day. So please study well and make it. Write it now. Units of work done. So we all people knows. Units of work done. So you can write it. So what is that actually? Units of work done is equals to units of work done is equals to units of force into units of displacement. Unit of displacement. So what is the units of force, everybody? Newton into units of displacement is what, everyone? Meter.
Meter.
So that is what. Now, the unit of work done is Newton meter. What is the unit of work done, everybody? Newton meter. But it is given with a name, another name which we used to call joule. So in the honor of the scientist name, call it as, your book also his name is there. What is the scientist name? James Prescott Joule. So in the honor of his name, the SI unit of work done, SI unit of work is joule. SI unit of work is joule, which will represent with a capital J. So that is why we'll say 1 joule is equals to 1 Newton into 1 meter. So we'll write it 1 joule, 1 Newton into 1 meter, which is equals to 1 joule. So this is what is the SI unit of work done. SI unit of work done is 1 Newton, sorry, joule actually. So 1 joule is equals to 1 Newton into 1 meter. That is what you have to remember. So now we'll define 1 joule. So it's very important one. Write it. Define 1 joule. All of you. A joule as the amount of work done. 1 joule as the amount of work done. Amount of work done when 1 Newton force. When 1 Newton force. How many Newton force? When 1 Newton force displaces a body by how many meters, Ra? How many meters, everybody? In
1 meter.
1 meter in its direction. In its direction. This is very, very important. In its direction. That is what we used to call it as a 1 joule. So I hope you are understanding. Next bigger unit. 1 kilojoule is equals to, that is what, small k capital J is equals to 10 power 3 joules. Same way, when megajoule is equals to, both remember, both capital letters, which is equals to 10 power 6 joules. All of you do it. So this is the SI system. SI system, what is the unit of work done, everybody? SI system, what is the unit of work done?
Joule.
Joule. That is what? Joule is equals to what?
1 meter into
Yeah.
1 meter.
Yeah. Joule is equals to 1 meter into 1 meter. That is what. Make it quick. Understand? Everyone? Yes, please.
Yes, sir.
Yeah. Nivedan, how are you?
Fine, sir.
Make it now. Next. Anything doubt, you can ask me. Are you clear, Mr. Pranav?
Yes, sir.
Yeah. Next. CGS system. What do you mean by CGS? Centimeter, gram,
Grams.
second. CGS system, unit of work is, what is that, anybody? CGS system, what is the unit of work? Sam, Prithvi, Sanjay, Mari. Yes, please.
Gram joules.
No.
Dyne,
Ah,
dyne
trouble.
into centimeter.
No.
Dyne into centimeter.
No. Dyne into centimeter, yes. That is force I taught you. Am I right, Nivedan? You are taking from the force only, yeah? So the
Yes, sir.
CGS unit of work is erg. ERG, erg. What does that call it as, Mr. Lingesh? Erg. So 1 erg means, again same. 1 erg is equals to, okay? So amount of work done by the force of, what is the CGS unit of force? CGS unit of force? Dyne. Remember, dyne in displacing a body by how many centimeters? Everybody. By how many centimeters, guys? By
1,
1
sir.
centimeter.
that is what. So 1 erg is equals to 1 dyne into 1 centimeter. So this is what is the CGS unit. Very, very important for competitive, or if you go for the higher classes and all. So everywhere we'll talk about this. Mr. Sam, okay, clear? Understand? Yes, please. Everybody, any doubt you can ask. So now, let me find the relationship between them. So we all knows that 1 joule is equals to, how many newtons, Ra? How many Newton into meters? All of you. 1 Newton into 1 meter. Note it, everybody. And note it, 1 Newton is equals to 1 lakh dynes, or we can say 10 power 5 dynes. Okay. So now 10 power 5 dynes into 1 meter is equals to how many centimeters? 1 meter is equals to how many centimeters? 100 centimeters, or we can say 10 power 2 centimeter. So I'll write 10 power 2. So 10 power 2 centimeter So 1 joule is equals to, note it, for example, 10 power 5 into 10 power 2, which is equals to 10 power 5 plus 2. So which is equals to 10 power 7. I hope you all knows, everybody. A power m into a power n, which is equals to a power m plus n. Yes or no? Girls? That
Yes,
is.
sir.
So 1 joule is equals to 10 power 7 erg. This is the most important relation between SI and CGS unit of work. So very, very important. So please kindly learn. Anyone having any doubt, you can ask me. More important thing about it. So here, all the things we are studying what? Work done by a constant what force? Work done by a constant horizontal force. That is what you have to remember. So that is only is our target. For 9th class, for school purpose, only we have horizontal force. Understanding? So work done by a constant force acting obliquely or at an angle with the horizontal. At an angle with the horizontal. Suppose force is applied like this, or the force is applied like this. This is the horizontal and force is applied horizontal. I already taught you. Understanding? But once again, we'll discuss it and we'll study. If it is applied horizontal, then what is the work done? How to calculate? That is all we'll discuss in the tomorrow's class. So till here, anybody having any doubt, you can ask me. Then tomorrow, inclined work done, force applied, angle with a horizontal, and types of work done, we'll discuss it and we'll finish it. Okay, everybody. So till here, do it. Anyone having any doubt, you can ask me, or else we'll proceed in the tomorrow's class. Are you clear, everybody? All you understand?